Since the beginning of the space age, NASA has explored our solar system, bringing back unprecedented scientific knowledge. But only a handful of these missions over the past 50 years have actually collected and returned samples from these far-off places. Astronauts on the Apollo program traveled to our moon, bringing back over 800 pounds of moon rock. Stardust was an unmanned mission that collected samples from the coma of Comet Wild-2 before returning them to Earth for in-depth scientific study. OSIRIS-REx is the most recently funded sample return mission that will launch in 2016 and return surface samples from an asteroid in 2023. The Comet Nucleus Sample Return mission will collect subsurface samples from a comet and return them to Earth. Comets and asteroids are leftover remnants from the early solar system, and by studying samples from these objects, we can learn more about the formation of our solar system and may find clues to the origin of life on Earth. Collecting a sample from a comet is a challenging feat for many reasons, including how far away they are from Earth and how little gravity they provide. In our concept, harpoons are used to collect and retrieve samples from interesting locations on these exotic objects. Traditionally, when collecting samples on Earth, we use scoops, shovels, or coring drills. But on comets and asteroids, there's so little gravity that you would push yourself off the surface if you used one of these methods. Harpoons allow you to grapple to the surface while taking a sample, allowing rapid sample collection and retrieval. First, we choose a specific interesting area to take a sample from, and then fire a sample collecting harpoon into that spot. As the harpoon penetrates into the comet, it fills its inner sample cartridge with subsurface material as it goes deeper. When it reaches its maximum depth, the sample cartridge closure mechanism shuts, trapping all the material inside it. The sample cartridge is then withdrawn from the outer harpoon sheath and pulled back into the spacecraft. The sample is then brought back to a terrestrial laboratory where scientists examine the collected samples in a pristine environment. Before we journey here, we need to work here in the lab studying comet and asteroid analogs. In order to determine how much energy is required to penetrate different depths in various density material, we've designed and built a harpoon test laboratory. Although the actual mission will use a cannon, for safety reasons we've employed a ballista to fire the harpoons. By correlating the imparted energy versus the penetration depth, we will know how to size the explosive charge for the actual mission. The Harpoon Lab allows us to study how the tip geometry, cross-section, and the mass of the harpoon affect its penetration. This has allowed us to optimize the harpoon sheath for a range of possible comet densities. Although sample return missions can be quite costly and complex, they offer important advantages over missions that study their subjects from a distance. Sample return missions allow terrestrial laboratories to study in far greater detail with a variety of techniques, and can even be studied by future generations with technologies that have not been invented yet.